Hello, I welcome you all. The problem reads determine the normal force, shear force, and moment at section passing through point C. Take P equal to 8 kilonewtons. Then in the second case, we're being told the cable fell when subjected to a tension of 2 kilonewtons. Determine the largest vertical load P the frame will support and calculate the internal normal force, shear force, and moment at a section passing through point C for this loading. So we'll start with case 1, which is to take P equal to 8 kilonewtons, and later on we're going to take the maximum tension that the cable can take of 2 kilonewtons, right? This problem is coming from the Engineering Mechanics and Statics textbook, 13th edition by R.C. Hibbeler. So quickly we're going to draw the free body diagram. We are going to section this cable here, okay? And we feel here the problem will be much faster to work on. You could section it here, but once you section it here, it means you need to take care of the forces that are going to be imposed here by the cable, right? So you'll have more work, okay? And yes, it's important to intelligently section the cable at a point that will make your work much faster. So we are going to have a tension force like so, and we are assuming, let's call this point, we have A, B, C, we call this point D, let's call this point E, and we call this point the joint where we have the pulley F. Alright, so one assumption that we have is the cable over this pulley is frictionless. There is no friction between the cable and the pulley, which makes the tension equal on cable D, F, and D. FB, of course, is a continuous cable, but the tension is going to be the same on both ends because there is no friction over the pulley. So we have T there, right? And then this height here, this one here is going to be equal to 0.5 plus 0.1, which is the radius of the pulley. Alright, so this becomes 0.6 meters. Great. Alright. So then we are going to use this portion. This is the portion that we're going to use when solving this particular problem. Alright. So then at A, where we have the hinge, we're going to have these reaction forces AY and AX. Okay. Alright, so quickly let's dive into the problem. Let's apply the equations of equilibrium. So we are starting with case 1 where P is equal to 2 kilonewtons. Right. So we have summation of forces about point A equal to 0. What do we have? We have P, which is a 2, causing a anti-clockwise positive moment, times 0.75 by 3, which is a 2.25. Okay, and then minus T times the lever arm, which is 0.6 equal to 0. And therefore, sorry, this is not 2, right? This is 8. Okay, this is 8. Okay, so this is 8 kilonewtons, and so is this one here. Alright, and therefore T is going to be equal to 8 by 2.25 divided by 0.6. This gives us T equal to 30 kilonewtons. And then we have summation of forces in the Y equal to 0. Okay, going up in our reference, what we have minus 8 plus AY equal to 0, and therefore our AY is just going to be equal to this one. I can write it directly, is equal to AY is equal to just 8 kilonewtons. And then finally we have summation of forces in the x direction equal to 0. What do we have? We have AX plus T equal to 0. Therefore, our AX is just going to be equal to minus T. Mind you, we already found what T is, so T, just replace T here. Okay, and once you do so, you realize that our AX is equal to T, which is just equal to minus 30. Minus just simply means direction will change for our AX. Direction will instead be like that. Okay, that will be the direction to be inwards, and we have AX equal to 30. We have AY equal to 8, and then we have T. T is equal to T is equal to 30 as well, right? So with this done, we can do a section. We can do a section at C quickly, and once we do a section at C, we are going to have the right hand section and the left hand section. Of course, we use the easiest, and of course the easiest is the left hand section. So let's draw it. So the left hand will look just like that. The right hand rather. The right hand will just look like that. This point is A. We have a force there of 8 kilonewtons. We have another one of let me push it a little bit in, just a little bit in, like so. Okay, I bring it here like this. This is our C. This force here is a 30, and then we have here the BC, we have MC, and then we also have a normal force NC. This length here is equal to this length here is equal to, let me create a boundary. Alright, this length here is equal to 0.75. Right, so then let's start applying the equations of equilibrium. Summation of moments about point C equal to 0 and clockwise being our reference. What do we have? We have 8 by 0.75, okay, and then minus MC equal to 0. Therefore, our MC is just going to be equal to 8 by 0.75. It's going to be equal to 6 kilonewton meters. And then we have summation of forces in the y direction equal to 0. Okay, going up in our reference. And we have VC plus 8 equal to 0, and therefore VC is just going to be equal to minus 8 kilonewtons. Okay, and then finally we have summation of forces in the x equal to 0. Going in this direction is our positive. Then we have minus NC minus 30 equal to 0. Therefore, our NC is just going to be equal to minus 30 kilonewtons, meaning it's in compression at that point. So we found MC, which is a positive moment at C. We found shear as a negative shear at C. And we find NC, which is an axial forces, also negative, meaning it's in compression. Alright, so with this, we can move on to part 2, where we are being told that so now we are moving to this point where we are being told that T max, let T max be equal to 2 kilonewtons. Then we are being asked to find P. Okay, in this case, find P, find the largest. This is 710, the largest vertical load P, and later the internal forces, at C. Okay, and internal forces at point C. Okay, so let's do that. So let's wrap this P. So we are going to use the same body, the same structure. Let's just get rid of these values because they will change. All right, so let's work out. So we have T. In this case, our T here is T max is equal to 2 kilonewtons. Okay, so then let's start applying the equations of equilibrium. Summation of moments about point A equal to 0, and clockwise being our reference. So we have T giving us a clockwise, which is a 2 times 0.6, and then plus P times 2.25 equal to 0. Therefore, P max, P max is going to be equal to minus 2 by 0.6 divided by 2.25. So this gives us a 0.5333 kilonewtons. So that is our P. With that P, we can find the reaction forces, so that I use the simplest section. So I'll say let's now find AY and AX. So just say summation of forces in the Y equal to 0. Okay, so we'll have minus P, which is just minus 2.5333, right? Okay, and then plus AY equal to 0, and then our AY is just going to be equal to 0.5333 kilonewtons. And then we also have summation of forces in the X equal to 0 in this direction, like so. So we have minus AX, okay, plus because we've already changed the direction. In this case, it's going this side. Okay, minus AX plus T, and our T we said is 2, so equal to 0. Therefore, AX is just going to be equal to 2 kilonewtons. Great. So after having found that, then we are going to do a section at the same point and use the simplest case. So here we found that our AX is equal to 2 kilonewtons, and our AY is equal to 0.5333 kilonewtons. Okay, so these are the values that we are going to use when we've done the sectioning. So we've done the section already, so we're just going to use the right hand side, which is simpler. Just move it a little bit somewhere there. All right, so let's replace that with the forces. So we have the 0.5333, we have a 2 there, this point is C, this is A. We have a shear of BC, a moment of MC, and the normal force of NC. And this length here is just equal to 0.75. Okay. So with this information, we can quickly start applying the equations of equilibrium, anti-clockwise being our reference. So what do we have? We have a positive moment of 0.5333 times the lever arm 0.75, okay, and then plus minus MC equal to 0. Therefore, our MC is just going to be equal to 0.5333 by 0.75 gives us a 0.3999, which is just a 0.40 kilonewtons meter. Okay. And then we have summation of forces in the y equal to 0. Alright. And then we have VC plus we have VC plus 0.5333 equal to 0, and therefore our VC is just minus 0.5333 kilonewtons. And then finally we have the summation of forces in the x direction. We have minus NC plus minus 2 equal to 0, and therefore NC is just going to be equal to minus 2 kilonewtons. Alright, so let's outline the final answers. We have the maximum value, or the largest Pmax over 0.5333 kilonewtons. We have MC of 0.4, and we have BC over negative 0.533, and then finally we have our shear, our normal force of negative 2. Right, kilonewtons. I hope the video was helpful. If it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.